Welcome to our detailed exploration of Part 3 of the National Building Code of Canada, focusing on fire protection, occupant safety, and accessibility. In this first batch, we are going to dive deep into Section 3.1.5, which covers non-combustible construction. We will look at the general rules and, more importantly, the specific, highly regulated exceptions where combustible materials are actually permitted in these buildings. Let us start with the fundamental rule in Article 3.1.5.1. If a building is required to be of non-combustible construction, you must use non-combustible materials. However, there is a scientific exception. A material can be used if it passes the ULC S135 cone calorimeter test at a heat flux of 50 kilowatts per square meter. It must have an average total heat release of not more than 3 megajoules per square meter and a smoke extinction area of not more than 1.0 square meter. The test must also run until it is absolutely clear no more heat or smoke will be released. But what happens if a material is made of multiple discrete layers? The code anticipates that an outer layer might protect the inner layers during a standard test. So if complete combustion doesn't occur, the test must be repeated by sequentially removing the outer layers until everything has been exposed or completely combusted. The crucial part here is that the acceptance criteria are based on the cumulative emissions from all layers combined, which still cannot exceed those strict heat and smoke limits. Moving on to Article 3.1.5.2, the code recognizes that building a 100% non-combustible structure is practically impossible due to minor components. Therefore, certain minor combustible items are explicitly permitted. This includes paint, self-adhesive tapes, mastics, and caulking materials used to seal exterior walls. You are also allowed to use combustible fire stops and fire blocks, as well as tubing for pneumatic controls, provided that the tubing has an outside diameter of not more than 10 millimeters. Continuing with minor components, the code also permits the use of combustible adhesives, vapor barriers, and sheathing papers. Electrical outlet and junction boxes can be combustible, and very importantly for interior finishing, you are allowed to use wood blocking concealed within wall assemblies. This wood blocking is essential because it provides a solid anchor for attaching heavy surface-mounted items like handrails and plumbing fixtures. Roofs present a unique challenge. Article 3.1.5.3 allows Class A, B, or C combustible roof coverings. You can even use combustible roof sheathing above a concrete deck, but only under very strict conditions. The concrete deck must be at least 50 millimeters thick, and the concealed roof space cannot be higher than 1 meter. Furthermore, this space must be divided by fire blocks, have protected openings, feature a non-combustible perimeter parapet, and contain absolutely no building services. Skylights are another area where combustible materials are allowed, but their size and spacing depend heavily on their flame spread rating. If the skylight has a flame spread rating up to 150, individual units are capped at 9 square meters, covering no more than 25% of the ceiling and must be spaced 2.5 meters apart. However, if you use a better performing material with a flame spread rating of 75 or less, the code relaxes these limits. You can have units up to 27 square meters, covering 33% of the ceiling, spaced only 1.2 meters apart. For vertical glazing, combustible materials are restricted to the first and second stories. Generally, they must have a flame spread rating of 75 or less. You can go up to 150 if the glazing is less than 25% of the wall area and the building is either single-story, fully sprinklered, or has proper separation between the first and second floors. Combustible window sashes and frames are also fine, provided they are separated by at least 1 meter of non-combustible construction vertically and don't take up more than 40% of the wall face. Exterior cladding is a critical safety vector. Combustible cladding is permitted on non-combustible buildings only if the building is 3 stories or less or if it is fully sprinklered. Additionally, the wall assembly must pass the rigorous CAN ULC S134 fire test. During this test, flames cannot spread more than 5 meters above the opening and the heat flux cannot exceed 35 kilowatts per square meter. If you are using fire-retardant treated wood, it must undergo an accelerated weathering test first to ensure the treatment doesn't wash away over time. Factory-assembled panels containing foamed plastic insulation are highly regulated because foamed plastics can burn intensely. They are allowed if the building is sprinklered, under 18 meters high, and does not contain assembly, care, or residential occupancies. Crucially, these panels must not contain any internal air spaces and must pass a full-scale room fire test. For walk-in coolers and freezers, the rules are similar, but the panels must be protected on both sides by sheet metal that is at least 0.38 millimeters thick, with a high melting point. Let's look at the inside of the building. Combustible interior finishes that are paper thin, specifically 1 millimeter or less, are generally permitted. For thicker wall finishes up to 25 millimeters, they must have a flame spread rating of 150 or less. Ceilings are stricter because fire spreads rapidly across them. Ceiling finishes must have a flame spread rating of 25 or less, though the code does allow up to 10% of a room's ceiling to have a rating up to 150, which is useful for decorative accents. Insulation is another major factor. Combustible insulation with a flame spread rating of 25 or less is permitted. If the rating is between 25 and 500, it must be separated from the adjacent space by a thermal barrier. Standard thermal barriers include half-inch gypsum board, lath and plaster, or masonry. However, if you are designing an unsprinklered building taller than 18 meters, the thermal barrier requirements become much stricter, requiring thicker Type X gypsum or thicker concrete to delay the temperature. We'll continue exploring these intricate material exceptions as we move forward. Picking up right where we left off, let's examine the specific code requirements for tents and air-supported structures. Because these structures lack the inherent fire resistance of traditional buildings, the code places strict limitations on them. For instance, they cannot be placed above the first story of another building, and they are strictly prohibited for institutional, residential, or high-hazard industrial occupancies, as well as classrooms. Furthermore, to prevent fire spread, they must maintain a minimum 3-meter clearance from other structures and be completely cleared of any flammable ground vegetation. Next, we need to discuss fire blocks in concealed spaces. Concealed spaces, like the hollow cavities inside stud walls or drop ceilings, are incredibly dangerous during a fire because they act like hidden chimneys, allowing flames and smoke to spread undetected. The code requires fire blocks at every floor and ceiling level to cut off these pathways. Additionally, these spaces are restricted in size, capped at 20 meters horizontally and 3 meters vertically, unless the cavity is completely filled with non-combustible insulation, which naturally prevents that chimney effect. This brings us to a foundational concept, how building size and construction type are dictated by the occupancy classification. For a Group B Division III care occupancy, the building can be up to 2 stories if it is fully sprinklered, but it still requires a 45-minute fire resistance rating for its floors. Conversely, a Group C residential building can go up to 3 stories with an increased allowable area, provided the floor assemblies have a full 1-hour fire resistance rating. Interestingly, if a residential unit spans multiple floors but has no other units above or below it, that internal floor rating can be waived. Spatial separation is a critical defense mechanism against fire spreading from one building to an adjacent property. The code strictly limits the area of unprotected openings, like standard windows, on an exposing building face. As the limiting distance, which is the distance to the property line, decreases, the allowable area for these unprotected openings shrinks drastically. For example, at a limiting distance of just 1.2 meters, an individual unprotected opening can be no larger than 0.35 square meters. This ensures that radiant heat from a fire cannot easily ignite a neighboring structure. Shifting our focus to occupant safety, let's look at egress doorways. A single door is often insufficient for safe evacuation. The code mandates a minimum of 2 egress doorways for high-hazard industrial spaces larger than 15 square meters or any room with an occupant load exceeding 60 people. To prevent a single localized fire from blocking both exits, these doors must be physically separated. Specifically, they must be placed apart by a distance equal to at least 1/3 of the room's maximum diagonal dimension. When occupants are utilizing stairs or ramps to evacuate, handrails are an essential life safety feature. The rules are highly specific. Stairs narrower than 1100 millimeters need only 1 handrail, but wider stairs, curved flights, and all ramps require handrails on both sides. Furthermore, for very wide monumental stairs, intermediate handrails must be installed so that a person is never more than 750 millimeters away from a graspable surface. The height is also strictly regulated, between 865 and 1070 millimeters, to ensure ergonomic support during a panic situation. Finally, we must consider the basic health requirements embedded in the building code, specifically regarding plumbing facilities. The baseline rule is that water closets must be provided for each sex, assuming a 50-50 split in the occupant load. However, the code provides practical exceptions. For instance, if a building has a total occupant load of 10 or fewer people, a single shared water closet is perfectly acceptable. We will dive deeper into how specific occupancy types alter these plumbing fixture calculations as we move forward.
Picking right up where we left off with building fire safety, let's look at how occupancy classifications dictate building size and construction requirements. For a Group B Division 3 care occupancy, the building can be either combustible or non-combustible, but it is strictly limited. It must be sprinklered, cannot exceed 1 story, and is capped at 600 square meters. On the other hand, Group D business occupancies of any height or area must generally be of non-combustible construction and fully sprinklered, with strict fire resistance ratings like 2 hours for floor assemblies.
Moving on to mercantile and industrial spaces. For Group E mercantile buildings up to 3 stories, you can use combustible or non-combustible materials, provided floor assemblies have at least a 45-minute fire resistance rating. If you add a sprinkler system, the allowable building area increases significantly. For Group F Division 2 medium hazard industrial buildings up to 4 stories, the rules are stricter. They must be non-combustible, fully sprinklered, and have at least a 1-hour fire resistance rating for floor assemblies and mezzanines.
Now, when exactly is a fire alarm system mandatory? The general rule is that if a building has an automatic sprinkler system, it must have a fire alarm system. But even if a building isn't sprinklered, an alarm system is required if it meets certain risk criteria. This includes buildings over 3 stories, places with a total occupant load over 300, schools with more than 40 people, or residential buildings sleeping more than 10 people. The goal is to ensure early warning in high-risk or densely populated environments.
Fire alarm systems generally fall into 2 categories, single-stage and 2-stage. A single system, required in high-hazard industrial occupancies, immediately sounds a general evacuation alarm the moment a detector or manual station is triggered. A 2-stage system, which is required in Group B care or detention occupancies, first sounds an alert signal to notify staff. If that alert isn't acknowledged within 5 minutes, it automatically escalates to a full alarm signal. This prevents panic and allows staff to investigate in sensitive environments. When the fire department arrives, they need to know exactly where the fire is. This is why annunciator panels must be installed near the main entrance facing the fire department access route. The annunciator breaks the building down into zones. In an unsprinklered building, a single zone cannot cover more than 2,000 square meters. In a sprinklered building, a zone is typically limited to a single story. Specific high-risk areas, like elevator shafts or contained use areas, must have their own dedicated zones on the panel. Smoke detectors are strategically placed to protect egress routes and vulnerable populations. You'll find them in residential public corridors, exit stair shafts, and sleeping rooms in care facilities. Importantly, they are also required in elevator machine rooms and lobbies. If smoke is detected in an elevator lobby, it triggers an automatic emergency recall. The elevators will immediately return to a designated safe floor, ensuring that occupants aren't accidentally delivered to a floor filled with smoke or fire.
Let's shift our focus to safety within the floor areas themselves, starting with suite separation. To prevent a fire from easily spreading from one tenant to another, suites must generally be separated by a fire separation with a 1-hour fire resistance rating. This can sometimes be reduced to 45 minutes, depending on the floor assembly ratings. Similarly, janitors' rooms, which often store combustible cleaning supplies, require a 1-hour separation, though this can be waived if the entire floor area is sprinklered.
When it comes to getting people out safely, travel distance and door swings are critical. Travel distance is measured along the actual path of travel to an exit. If a suite is properly fire separated, you can start measuring from the suite's door, rather than deep inside the room. As for doors opening into corridors, they must swing on a vertical axis. Crucially, if a room holds more than 60 people or contains a high-hazard industrial occupancy, the door must swing outward in the direction of exit travel to prevent crowd crush.
Assembly occupancies like theaters or arenas have very specific rules for aisles because of the high density of people. The standard minimum clear width for an aisle is 1,100 millimeters. If the floor slopes more than 1 in 8, the aisle must be stepped, with strictly regulated riser heights and tread widths to prevent tripping. Also, to ensure people don't get trapped in an emergency, dead-end aisles are strictly limited to a maximum length of 6 meters.
The integrity of an exit is absolute. Once an occupant reaches an exit stairwell, they must be protected from the rest of the building. Therefore, the fire separation in closing an exit can have almost no openings, other than the exit doors themselves and essential piping. You cannot install fuel-fired appliances in an exit, you cannot use the exit as an air return plenum for the HVAC system, and you absolutely cannot have storage rooms, washrooms, or service rooms opening directly into an exit enclosure. Exit doors must be foolproof.
The release hardware must allow the door to open from the inside with a single operation. No keys, no special tools, and no secret knowledge required. Electromagnetic locks are allowed, but they are heavily regulated. They must instantly release if the fire alarm goes off or if the building loses power. Additionally, applying pressure to the door hardware must initiate an irreversible process that unlocks the door within 15 seconds, ensuring nobody is ever locked inside during an emergency.
Shifting to health requirements, the code dictates the ratio of lavatories to water closets. You need at least one sink for a room with 1 or 2 toilets, and another sink for every 2 additional toilets. To maintain hygiene and accessibility, the faucets must either be automatic or have manual controls that don't require you to hold them down continuously. If they are metered push-button faucets, they must provide at least 10 seconds of water flow per push.
Accessibility is a major component of the building code. At least 50% of a building's pedestrian entrances must be barrier-free, accessible directly from the sidewalk or via a ramp. Once inside, a barrier-free path of travel must be provided throughout the entrance story and to any other occupied floor served by an elevator. There are practical exceptions, of course. You don't need to provide wheelchair access to elevator machine rooms, crawl spaces, or high-hazard industrial areas.
Finally, let's look at power doors and washrooms. Power door operators are mandatory at barrier-free entrances for hotels, care facilities, and larger public buildings over 500 square meters. For plumbing, any story that requires a barrier-free path of travel must also have barrier-free washrooms. These must feature accessible toilets, sinks, and mirrors. If you are altering an existing building, installing a standalone universal washroom is an acceptable alternative to retrofitting the general public washrooms. We will explore the specific dimensions and design standards for these accessible features in the next segment.
Continuing our discussion on building safety, let's look at floor areas that have a barrier-free path of travel but are not fully sprinklered. In these cases, the code requires specific protections to ensure occupants with physical disabilities can safely wait for rescue or evacuate. This includes providing a specially protected elevator, dividing the floor area into at least 2 zones separated by fire separations, or providing accessible balconies in residential buildings. The goal is to create safe areas of refuge. When it comes to the means of egress, even sliding doors must be designed to swing open on a vertical axis when pushed, ensuring they don't impede a panicked crowd. We also have strict formulas for calculating the capacity of these access routes. For most corridors and doorways, the required width is based on 6.1 millimeters per person. However, in care or treatment facilities where patients may need to be moved in beds or wheelchairs, that requirement triples to 18.4 millimeters per person to accommodate the extra space needed. Moving on to specific room hazards, common laundry rooms in residential buildings must be enclosed by a fire separation of at least 1 hour, unless the entire floor area is sprinklered. Another critical separation is between storage garages and assembly, care, or residential occupancies. Here, the code often requires a ventilated vestibule. This vestibule acts as an airlock, preventing hazardous exhaust fumes and potential fires in the garage from easily spreading into the occupied areas of the building. Exits must be strategically located to ensure no one has to travel too far to reach safety. The maximum travel distance varies heavily by occupancy. For high-hazard industrial areas, you can only travel 25 meters before reaching an exit. But in a fully sprinklered building with a massive, tall public corridor, that distance can be extended up to 105 meters. Additionally, while horizontal exits, moving into an adjacent fire compartment, are useful, they generally cannot make up more than half of the required exits from any floor area. The physical design of the egress path is just as regulated. A flight of interior stairs must have at least 3 risers to prevent tripping hazards associated with single steps. Ramps have maximum slopes depending on the occupancy. For instance, a gentler 1 in 10 slope is required for care and residential buildings, while industrial settings allow a steeper 1 in 6 slope. And crucially, almost all exit doors must swing outward in the direction of travel, so that a fleeing crowd doesn't get trapped against an inward opening door. Security is a major concern for banks and retail stores, which sometimes conflicts with egress rules. The code offers an exception for these spaces if the building is fully sprinklered. They can use specialized locks, but absolutely cannot lock the doors while the public is inside. They must also post clear signage stating this rule. For staff working after hours, the emergency egress doors must be tied to the fire alarm or sprinkler system, ensuring they instantly unlock if an emergency occurs. Building services also require careful fire protection. Elevator machine rooms must be enclosed by fire separations matching the rating of the hoistway they serve.
Linen and refuse chutes are essentially vertical chimneys that can rapidly spread fire and smoke. Therefore, they must be built of non-combustible materials, enclosed in rated shafts, vented through the roof, and heavily protected with sprinklers at the top, at alternate floor levels, and inside the discharge room at the bottom.
Shifting to accessibility, the code mandates strict dimensions for barrier-free paths. Ramps must be at least 870 millimeters wide, with level landings every 9 meters to allow users to rest. Doors in a barrier-free path must provide a clear opening of at least 800 millimeters. To ensure they are actually usable, interior doors cannot require more than 22 newtons of force to open, and many key entrances must be equipped with power door operators.
Finally, accessible washrooms require precise layouts. An accessible stall must be at least 1,500 by 1,500 millimeters to allow wheelchair maneuverability, featuring an outward swinging door and specifically placed L-shaped grab bars. Universal washrooms must also provide a 1,500 millimeter turning circle and feature hardware that can be operated with a closed fist, requiring no tight grasping or twisting of the wrist, which sets up the framework for the specialized facility requirements we will cover next.
Let us look at the requirements for Group C occupancies that are up to 6 stories high. For these buildings, non-combustible construction is mandatory, and they must be fully sprinklered. Additionally, the floor assemblies and any mezzanines must maintain a fire resistance rating of at least 1 hour to ensure adequate protection between levels.
Moving on to business, personal services, and industrial occupancies, the code scales the construction requirements based on the hazard level. Group D and Group F Division 1 buildings can reach up to 3 stories if they are fully sprinklered, while Group F Division 2 is capped at 2 stories under these specific area limits. In all these cases, a 45-minute fire resistance rating is required for floor assemblies.
High buildings present unique challenges, particularly regarding smoke movement. The code mandates that exit stairs must remain highly tenable, containing no more than 1% of contaminated air by volume for 2 hours after a fire starts. To achieve this, stairways must vent directly to the outdoors, and mechanical air-moving fans must be controllable from a central alarm facility.
Seriously, in high-rise emergencies, elevators become critical tools for first responders. The code requires manual emergency recall for all elevators, and at least one specific elevator designed for firefighter use. This elevator must be capable of carrying a 900-kilogram load to the top floor in under 1 minute, operating safely even under fire exposure.
When an exit opens into an interconnected floor space, it must be protected by a vestibule. This vestibule acts as an airlock. By keeping the doorways at least 1.8 meters apart, it effectively limits the passage of smoke, ensuring the main exit stair shaft remains safe and clear for evacuation.
Modern buildings rely on multiple interconnected safety systems. It is not enough to test a fire alarm or a smoke exhaust system in isolation. The code requires that when fire protection and life safety systems are integrated, they must be tested as a complete, unified whole to verify that they interact and function correctly during an emergency.
Safety within floor areas relies heavily on clear means of egress. If a roof or terrace is intended for occupancy and holds more than 60 people, it must have at least 2 separate means of egress. Additionally, strict headroom clearances must be maintained throughout all access routes to ensure occupants can evacuate without obstruction. Egress doors must never trap an occupant. They must provide a clear opening of at least 800 millimeters and open easily without keys or special knowledge. Furthermore, to prevent falls, guards at least 1,070 millimeters high are required at raised floors and balconies, with strict limits on opening sizes to protect children. Different occupancies require tailored fire separations. For instance, in assembly occupancies, seating areas holding more than 200 people need a 1-hour fire separation. Similarly, residential suites must be separated from each other and the rest of the building by a 1-hour rating, though this can sometimes be reduced to 45 minutes depending on the building's overall construction. Basements present a severe risk if explosive gases or dusts accumulate. Therefore, the code prohibits storing or handling volatile materials that generate explosive mixtures in basements. When dangerous goods like oxidizers or reactive materials are stored elsewhere in the building, they must be isolated by a robust 2-hour fire separation. The fundamental rule of egress is redundancy. Every floor area generally requires at least 2 exits. These exits must be physically separated so that a single fire event cannot compromise both routes simultaneously. There are minor exceptions allowing a single exit in very small, low-occupancy buildings, provided strict travel distance limits are met. To guide occupants safely, exit signs are mandatory in buildings over 2 stories or with occupant loads exceeding 150. Canada uses the internationally recognized green and white graphical symbols. These signs must be continuously illuminated and connected to an emergency power supply, so they remain visible even during a total power failure.
Stairs are a common site for accidents during an evacuation, which is why their geometry is strictly regulated. A single flight cannot rise more than 3.7 meters without a landing. Furthermore, the run and rise of the steps must be highly uniform, with a maximum tolerance of just 5 millimeters between adjacent steps to prevent tripping. Service spaces often contain high fire loads or ignition sources. Rooms storing combustible refuse must have a 1-hour fire separation and sprinklers. Electrical vaults require even heavier protection, up to 3 hours. Additionally, the ductwork running through the building must generally be non-combustible, and any sealants or tape used must meet strict flame resistance standards.
Self-service storage buildings have their own specific section in the code. They're classified as medium-hazard industrial occupancies. To mitigate the risk of unknown stored materials, these buildings are restricted to a single story with external access only. Internally, they must either be fully sprinklered or subdivided into compartments of no more than 500 square meters, using 1-hour fire separations.
To wrap up our review of these building code requirements, remember that construction limits are always scaled to the occupancy hazard. High-rise buildings demand complex smoke control and emergency access systems. Egress routes must be reliable, redundant, and clearly marked, while hazardous service areas must be strictly isolated. Finally, all these life safety systems must be tested together to ensure they protect occupants when it matters most.